computer. Okay, so today, one of the things that at least someone said when we did the Fibonacci sequence is, gosh, this seems like something that is really dumb to do many times. Isn't there something that we can use that will just do this for us? And today, the answer. So for loops or not for loops, that is the question. So the deal with the Fibonacci sequence code, if I can find it again, there we go, is, just pull that up here. To the odd checker, free Q, so in sub-practice Fibonacci. There we are. So we have our Fibonacci sequence code. Looks something vaguely like, oh, can't drag it all the way over. Something vaguely like this. So we set our first number. Oops, sorry, and there's something that got pasted in the middle that shouldn't be there. There we are. So our first number, we set our second number, and essentially just copy pasted those 4 lines of code about a bajillion times. Yeah, and that was the Fibonacci sequence. And if I run this, gosh darn it, if it doesn't actually work. But our goal is to not copy paste those 4 lines of code a billion times. It's to just do it once and tell the code how many times you want it to happen. You can think of where this would be a useful thing. Like if I have to look at, if you're a petroleum person, a well log where you have all the data that you want given every 6 inches for 5,000 feet. It'd be really nice not to look at that by hand. If you want to think of an environmental thing, if you have about 2 years worth of sawn data, you don't want to do the corrections to every single data point by hand. It'd be awful nice to have code to do it for you, just to cycle through every data point. There are a bajillion applications. Essentially, any problem that's useful and involves data is going to have some operation that you're going to want to do a bajillion times, and you're not going to want to do it because you shouldn't. So let's play. For loops or not for loops? The answer is you're always for loops. So nice if I was on the page. So the loops that we're going to talk about both do the same sort of thing. They both enable some sort of automatic repetition. It lets you run the same code a whole bunch of times. And the 2 loops that we're talking about are for loops and while loops. They both loop on a section of code. The question is, if I am having the code loop, how many times is it going to do that? And when does it stop? And that's really the difference. So let's have a look. Looking at the for loop first. So this is the basic syntax for a for loop. It should be more, if I'm being more specific, this bit here is the actual for loop. So where it says for, and then anything that's indented inside of that, just like an if statement, what you call Python uses indents to show what's included inside of a structure. So use it for ifs, use it for fors, use it for while loops, whatever. The important bits here, so the important thing about a for loop is that it counts how many times it goes through a loop as it goes. So in this, so in this example, I can tell the loop how many times I want it to run. So it's kind of pedantic to talk through it. So let's throw it into Thorny. I want to close that presentation so that I can do this. Discard those. Second as it figures out what the heck it's doing. There we go. All right, so I'm going to open up a new code in this. I'm going to save it as loop examples. Okay, so example of different loops. I'm going to throw that into my comment line. Okay, so it's going to do examples of the loop. You know what? Let's just do something dead simple. Let's just focus on like how the loop works. We're just going to add up numbers between say 1 and 10. Cool. So we're just going to add numbers between 1 and 10. So I'm going to say this code will add up all numbers 1 to 10. Great. All right. So if I did that by hand, I could just say that the summation is just 1 plus 2 plus 3 plus 4 plus 5 plus 6, blah, 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 right? But I don't want to write all that out. I want to have a loop do this automatically so I can just tell it to sum whatever the crap I want it to sum. So we're not going to write it out. We're going to try to do it with a loop. So first things first. If I start with like number like that, and I want to key, and I thought of this from like a loop point of view. The first time I would have that. The second time I would want to go like that. Third time I'd want to go like that, right? That if I was just going one addition at a time, that's kind of how I do it. I'd add one number, then I add the next number, and the next one, the next one. Hope I'm not going too pedantic with this, but that's what's called. But when you're working with a loop, it's one operation at a time. So in this case, I'm setting some starting place, and then each time through the loop, I add kind of the next number in the sequence up until I get to 10. I haven't actually made a loop yet. If you're trying to wonder about that, I'm just trying to set up the thought process here. All right. So I'd like my loop to do something like that. That's what I want my loop to do. Really, that's what it is going to do. All right. So I'll just write loop based on how it acts. We'll do something like this. I'm just going to comment those lines out quick. They're just for example. So what that looks like in code is something like this. I start off on a number, say x equals 1. I'm just spacing up a little bit so it's not sitting on the bottom of the screen. Then I start my for loop. So for, I have to have some counter variable. We said that a for loop counts how many times it goes through the loop. So I have to have some variable. I'll use I. And then I have to tell it what it's counting from and what it's counting to and how big of a step it's taking to get there. So I'm going to use the function called range. So for I in range, say 0, 10, 1. End it with a colon. All right. Well, before we get into the logistics of adding stuff up, let's just see what that does. What's called what I is. So I'm just going to print I. If I run that, look down at the bottom, and it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I started at 0. That first number in range is where I will start. It will run up until 10. So if I think of each time through this loop, I changes. When I get to 10, I'll stop. Now you might think, well, wait a second. It only got to 9. What the heck? Don't lie, brother Mario. It's bad. Well, let's walk through this. So let's go through it one step at a time. So when I get into my for loop here, first thing it's going to do is pick a first value for I. It's going to start at 0. So that's that first number in the range, right? Okay, it goes down, it goes into the for loop. It says, okay, the first thing in the for loop is print I. Well, I is 0, so I'm going to print that. Great, done. When it finishes everything that's in the for loop, it pops right back up to the top, and it moves I to the next value. So I said I started at 0. That last number there, that 1, that's how much I will change by each time I go through the loop. So I start at 0. I'm now advancing by 1. So now I is at 1. Go into the loop. I do whatever's there. Print 1. Great. Back up to the top. I'm at 2. And I just keep on going like that. I is now 3. Next value of I is, anyone? 4. There you go. Next value, 5, and goes on and on and on. Okay, there's I equals 9. And then it stops. What would the next value of I been? 10. And that's where that second number said to stop. Because as soon as I changed to 10, it said, okay, I'm done. I'm not going to do this loop because I was told to stop when I equals 10. So that second number in the range command controls when the loop stops. That said, how many iterations did I go through? How many times did the loop run? 10 times. If I count all the numbers that got printed out, it ran that print statement 10 times. So if I abbreviate this, just say range 10, I can run this again. It'll assume that I start at 0. I can go down here. First number out is 0. It assumes that the step value is 1. And it takes the end value to be to 10. So if you just want it to run 10 times, and you don't care if it starts at 0 and you don't care that it moves by 1, you can just say for I in range 10 and call it quits. Cool beans? Sweet. All right. So that's that. Now we said we want to throw this at the problem of counting, of adding, really. So I have kind of my starting number, 1, and I want to add all the numbers from 1 to 10, including 10, let's say. So I need to run this loop 10 times. Cool. All right. Well, this loop will run 10 times. That's no problem. And conveniently, the loop also gives me pretty much all the numbers between 1 and 10. At least I can make it do that, right? How would I make it give me a 10, though? Because right now it'll give me from 0 to 9. How would I make it give me a 10? Yeah.
11.
Yeah. And if I didn't want it to start at 0, how do I make it not start at 0? I'll make it start at like 1. You got it. So, and I can check that, just say print I. There's 10, there's 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. So I get everything from 1 to 10. Awesome. So if I takes on all the values from 1 to 10, heck, I could, as long as I can add up I every time, like I have exactly what I need, right? So that's what I'm going to do. I'm going to store everything in this variable x and just say x equals I. So I can collect the value of I each time around. But that's great, but it's not going to do what I want, right? Because each time x is just going to get overwritten. Like the first time x will be 1, then it'll be 2, then it'll be 3. It won't be 1 plus 2 plus 3 plus 4, right? So what if I did that? I'll just make that 0 just for kicks. So the first time through this loop, see, let's just do this. So I'm on line 20, so I'm on line 21. Let's just step through this code one line at a time. I'm on line 21. What happens here? Yeah.
So is x equals 0.
Okay, so the value of x is now 0. Great. All right. Now what? What's the first value of I? What happens since here? Yeah, right. So we just started the for loop. I is 1 because we've told it to go from 1 to 11. Yeah.
I don't understand why you have to put the iterations at 11 because it seems like it's only doing 10 iterations.
It is. However, in the way that I'm thinking about adding things up, I could try to finagle some way of adding a new value from 1 to 10 each time I go through the loop. But if I is already counting from 1 to 10 for me, I might as well make it just do everything. I might as well just use that value. However, that means that I'm missing the number 10 if I do it in range 10, right? So if I go from 1, so if I do in range 1, 11, I get all the values from 1 to 10.
Okay, so it's more of a
yeah. Let's run through this, see if it answers your question, and we'll.
If it's a range, then shouldn't it not include 1?
That's the thing. You can't think of it as like a 1 to 11 not inclusive thing. It's when it starts at 1. Like that number is a starting point. The 11 is, it ends as, so every time that you go through the loop, you always come back up to the top and advance that number by 1, right? So first time you go through, it's 1, then it's 2, then it's 3. And each time you change it, you say, okay, it says, okay, I equals 3. Okay, I'm still less than that n number. I'll run whatever's in the loop. And when you're done, you come back up, say, okay, now I'm 4. Okay, I'm still less than 11. Okay, go through the loop. Okay, I'm 5, still less than 11. Again and again and again until it gets back up here. It's I equals 10. Okay, I'm still less than 11. Go through the loop. Okay, I equals 11 now. Oh, nope, I'm at the end. I'm done.
Okay.
So you never run the loop with that with the ending number.
So if you did like a step size of like 2, then it would have much like less iteration.
Correct.
Okay.
Yes. If I had a step size of 2 in here, it would finish at I equals 10. If I had a step size of 3, it would finish at I equals 9. If I had a step size of 4, it would finish at I equals 8.
Okay.
Yeah.
Gotcha.
The 11 is not the number of iterations, it's the end, it's the value of I that is the end of the loop.
Okay.
Yeah. Cool. All right, so first time through the loop, I equals 1. Where do I go from where do I go from here? What's my next line I go to? Yeah.
Would it be the next line down?
Yep. So what's the value of I? 1. What's the value of x? 0. All right, great. Now x equals 1. Okay. The value of x was 0. It's now 1. Great. I'm all done there. I pop back up to the start of the for loop. I is now 2. Yes. Why is there no third value in the parentheses? Because it's optional. If it's not listed, it's assumed to be 1. In the same way, the first value is also optional. If it's not there, it's assumed to be 0. If there's only one value listed, it is assumed to be your ending value. All right. So I is now 2. I go back into the loop. What's the value of x? I just call it after I run this line. Yeah, 3, right? Because I is now 2, and well, X, well, it's 1. So now X is 3. So you see what this loop is doing. It's constant, which call because I can, because whatever on the right is stored on the left, I can use X to redefine itself, which is super handy. So let's just do another couple iterations here. So after this line runs, X is 3. Where do I go now?
Back up to the,
Yep. Is that what you're going to say, Vincent?
Yeah.
Cool. So back up here, I is now 3. Come back down here. X is now. So I just became 3. From last time, X was also 3. The new value of X is 6. Sweet. All right. Where do we go from here? And what's the new value of I? 4. Sweet. So I go back up to the top. I is now 4. We keep on going through this. There's 6, 7, 8, almost there, 9.
What button is that you hit again to go through the different steps it does?
F7. But you have to have function lock on. You can also click up here. It's the so you have the green play button, you have the debug button, and then there are a whole bunch of arrows next to it. The second one in that says step into will let you do the same thing. All right. So I is now 10. I come down in here. I add up that. X is 55. What happens next?
stops.
It stops. Why? Say again.
You ran through your 11 interval.
Yep, let's call it. Or rather, the next time I would go back up to line 22, the value of I is going to be 11, which means that it's hit the end of the range that I've asked it to do. So next one, done. And it says X equals 55 after I added all those up. Do we have any number trivia people? Is that actually the sum from 1 to 10? The sum of all numbers from 1 to 10? Yes, it is. Sweet. So awesome. I didn't have to type out more than 3 lines into code to do like 10 lines of code worth of work. This is great. I'm pretty psyched. Any questions on like the basics here? Yeah.
So if you were to include 0 at the very beginning, you just type 11. I don't understand what it means.
Yep. So if I do that here, I'll print the value of I each time around. I'll just put a gap between each thing. Fun fact, if you just put print with empty quotes, it'll just print an empty line. So I'm printing the value of I each time around. Starts at 0, goes up through 10. And that's with the command range 11. So it's ending at the same place, but it started at 0. Right. Any other questions? Great. All right. So that's a for loop. Almost there. All right. All right. So we talked about that. Again, you can change that step size if you want. The I, the variable I, okay, is what's called the loop, the loop variable. One note about that: you never want to redefine that inside of the loop. You might think of it as the for. Each time we went through that for loop, I needed that value of I that was related directly to what iteration that I was on, right? If you change what the value of that is, it's going to screw everything in up. So don't. This is why when we talked about variable names, said you don't use I, J, K, those variables for your regular variable names. Save them just for your loops, just for your loop variables, so that you know that you don't use them for anything else, and then kind of saves you from messing yourself up. One thing that's kind of neat about Python is this range guy is one example of what's called an iterator. Essentially, every time that you go through the loop, that iterator is what tells the loop variable what its value is each time that you go through. Python's kind of cool or annoying, depending on if you're a computer science person or not, because that iterator can be almost anything. So if I go back into Thorny, I can say for I in range, I'll give it a word Python, and I'll just print whatever the loop variable is. I'll run that, and it spits out the letters of that word. If I put a file in there, it would spit out the lines of the file. So in a week or two, that's what we're going to do with a 1,000-line data set. We're going to read that data set in, throw that into a loop, and just read lines out of the data set. It's super handy, but we'll cover that another day. All righty. Cool. All right. So ways to get errors in for loops. Defining the range with floats. Floats are what again? Yeah. Right. If you put anything with a decimal into the range function, Python will slap you in the face. And if it won't, I will. Oh, so only use integers. If you don't, you'll be sorry. So that's probably the easiest way to shoot yourself in the foot. It's called, once you get into a loop, you're kind of in it until it's done, unless you use one of these commands. So if you are in some sort of situation where you just need to end the loop, you can do that using the break command. So let's see if we can run this quick. So update share. Here we go. Bless you. All right. So say that I have my loop here. I'm just going to roll it back a bit, so I'm back into my addition thing. I'm going to stop. I'm going to come into this loop, and just for an example, I'm going to say that I want to stop this loop the first time that it's run. So I'm going to write break in there, run it. Oh, I probably should print something too, so that we know where we are. There you go. Ran it. This loop has only run once. We can tell that because otherwise we would have seen more than one thing print, right? Let's move this around. So I'm going to take the break statement. I'm going to put it up top. What happened? The code just ran, nothing came out. What just happened?
Ran it 0 times.
No, it still ran once. But where would it had to have stopped in order for it not to print? Yeah, Vincent?
I was going to say X is no longer defined, but it's just under the 4 words.
Correct. Yeah. Where did it stop? Yeah.
Stopped at the break.
Yes. Yeah. Break is where it stops. So if I move the break statement down to here. So right now, value of X is 0, right? Value of X is now 1. It didn't print anything, but it did update the value of X. It ran line 23. It ran until it hit the break statement. Then it stopped. I can also I can also do something like say, I only want to run this thing twice. So if I equals 2 break, that is something that I can say. Actually, if I want to run it twice, this should be 3. So I can run that. Huh, I guess I can't do math. Oh yeah. And loops run 3 times because the first time through this loop, what's my value of I? First time through the loop, value of I is 1. I come down here to line 23, value of I is 1, value of X is 0, so X is 1, print 1. This is true or false, that first time through? False, right. So it doesn't run the break statement. It just keeps on going until it does. So you can definitely use break in order to get yourself out of a loop in a hurry if you need to. I emphasize the if you need to, because you can also screw yourself over by using break really easily. If there's a condition that you don't expect, if there's some combination of terms that you don't think will happen, that will cause you to leave the loop early, you're suddenly not going to have however many iterations that you thought that you were going to have. So it is something to use sparingly. If it does what you want to do, great, but just be careful. Something else that you can use is the keyword continue. So I'm going to run this. I'm also going to just at the end here, I'm just going to print the value of X. If we add up all the numbers from 1 to 10, I should see 55 print twice, right? Once from the end of the loop and once after. Yeah. So I should see 55 print twice here. Or instead I get a 0. That's annoying. What the heck? But if I look over at my little variable window here, I did go from 1 to 10. Value of I is 10. The loop ran 10 times, but nothing in here actually happened. And that's because of this guy. Obviously. But let's see what happens if we put it there. Now we get 55. What is the continue doing? Yeah.
Send it back up to the loop statement.
Yeah, so each time that I get to the line with the continue command on it, it just skips everything after that. It just goes straight up to the top of the loop and does the next iteration. So if I went through this line by line, start on line 21, okay, X is 0. Okay, first time through, I is 1. Okay, 1 plus 0 is 1. Continue. Okay, I'm back up here. I is now 2. 2 plus 1 is 3. Continue. Okay, skip back up to the top, and so on and so on and so forth. Any questions on that?
Why do you have print twice?
Just to show what it happens. Because here, if I don't have this continue command, how many numbers should get printed out here if I don't have that continue command? Say again? Not 2. 2, 1, any other? Okay, and all of them is how many? Just for reference.
10 numbers?
Yes, because that loop's running 10 times, right? For I in range 1, 11, it's called, it'll loop while I is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it'll print 1 more. This should print 11 numbers off. There we go, and which I'll with the last number in the addition sequence being repeated. If I leave that continue in, all I get is that print statement there running. So so to answer your question, Kevin, it prints there twice because it's a nice, because it's a really handy example. That's it.
I'm still kind of like lost on what continue is doing.
Okay, so let's go through this line by line with this guy. All right, so I'm in my loop, yeah. In the loop first time through. Okay, x is 1, I is 0. Add those together, store them as x. The next line is going to be the line with the continue command in it. Instead of finishing the loop, it's just going to skip back up to the top. So the continue command skips everything else in the loop and goes on to the next iteration. In its present context, it makes no sense for me to have that print statement there. Where you might use this is, say, if there's something that would make you want to skip a section of your loop. So say there was a thing and on I equals 4, I want to not print something. I can put that continue statement inside of an if statement, and it'll skip printing that one time. So I can go back through here and my 1, 2, 3, I should have a 9 between the 6 between the 6 and the 5th and the 15, or a 10 between the 6th and the 5th and the 5th and 15, right? So that'd be the kind of use that you'd probably see for it. Cool beans? Does that answer your question, Kevin?
Yeah.
Cool. All right. So those are two, how do I say it? Two different options you have for using loops. Break and continue work in, I said we have two kinds of loops. You have a while and a for. Break and continue will work in both. If I'm having to use them in a for loop. They'll work well in either. Yeah.
Break and continue work together if using the function.
Like if I, wait, where's my mouse? Like if I go, say, something like that. Which are you asking, like, will that do something?
Yeah.
Good. Yeah. And if I equals 4, it'll continue to the next 6 iteration. And if I equals 5, it'll stop. So if I run that, bam. Yeah. It continued on in the 4th, and then it broke on the 5th. All right. Any questions? Great. All right. So that's that. We'll just pop you back over here. All right. So there's my thing. Oh, come on. Go on to the next slide. Okay, talked about that. Sweet. While loops, they're the other kind of loops. So if I want a loop to go 5,000 times, or say I have like a file that I want to iterate through, for loops are great. For loops will do whatever I want. They're easy to control. I can say, hey, you go from here to here, and it'll just do it. That's awesome. However, sometimes there are conditions. For example, we might want, if we're looking for, say we're iterating through a list of stream depth data, and it's data taken at a point for like a year. We want to find when the deepest that stream has been. We might want to loop through that data until we hit a certain depth, right? So with a while loop, you can do that directly. A while loop is set up to run while a certain condition is true. And it will check that condition at the start of each loop. So in this case, this loop runs while x is less than or equal to 3. So let's have a look at this puppy. Just going to So it's my while loop example. I'm just showing my for loop. I'm just going to get rid of that for a second. All right, so I'm going to say while x is less than or equal to 3. And inside of that, I'm going to say each time, oops, sorry, each time you run this loop, where'd my mouse go? There you are. Each time you run through this loop, take x, add 1 to it, save that as x. Okay, so if I went through this line by line, it would look something like this. So first time through, come down to line 21, my very first line of code. That the value of x is now what? 0, right? Move down to the next thing. So there's my condition. Is this condition true right now? Right, because x is 0, 0 is less than or equal to 3. That is true. Great. And if it's true, I'm going to do everything inside of the while loop. That's everything that's indented right after the while. So come down here. The value of x is now, after I run this line, that it is 1, right? Because x 0, 0 plus 1 is 1. Store that, done. Okay, is this true? Right, it is. Because 1 is now the value of x. 1 is less than or equal to 3. Okay, it's true. Do everything here. Value of x is now 2. Great. Come back up here. Value of x is 2. Okay, 2 is still less than or equal to 3. Great, that's true. Okay, we'll do whatever's in here. That's now 3. Is this still true? 3 is less than or equal to 3. Okay, this is still true. Yep. X is now 4. Is this true? No, it's not. It's false. I'm done. It skips over the rest of the loop and moves on with life, same as the for loop. If I had a print statement just chilling out here, and I ran this, I'd see the value of x at the end of the while loop. Cool beans? All right, so that's a while loop in a nutshell. I can make this condition as complex as I want. I can say, well, x is less than or equal to 3, and I don't know, x is greater than 1 or whatever. I can put as many, I can nuance that however I want. Any question that I could ask in an if statement, I can ask here. And that'll become the deciding factor as to whether or not the loop will run. Cool beans? All right, so let's try this. What will happen here? What will this code do?
Not forever, right?
No, no.
Okay, yes.
It'll print 0.
We'll print 0.
I just have a question.
Yeah. Oh, yeah, sure. Yeah. Question.
So for statements basically kind of like just a simple range loop. And then a while just conditional loop.
Yeah.
So because
Yeah.
Yeah.
Sorry. Yeah.
It'll have to print 0.
Yes. And why is that?
Because the while statement isn't true, so it'll skip that.
Right. So as it presently stands, line 21 says x equals 0. This loop will only run while x is greater than 0. 0 is not greater than 0. It's false. It never runs the loop.
What if you put or equal to, then what would it do?
You tell me. You tell me. Is that ever going to be false? No. It will run forever and will crash your computer.
Really?
Yes. So don't do it unless you really want to. If you end up getting stuck in this, so if you do that, okay, it is running now. A way to get out is hitting Control-C as many times as you can. Just click into that bottom window and hit Control-C a whole bunch of times. It's the only way to stop it because else it will just run forever. So
You hit the stop button.
you might be able to but case in point. It's going, there it is. What you call it? Essentially, you have to click the stop button when it's not executing a command. It's easy just to hold down Control C. All right, so that's an infinite loop. Watch your conditions to make sure that you don't get into one, because it's not going to do anyone any good. Although it is kind of cool to watch the numbers scroll by. So Control C is your best friend. All righty. So there you go. Make sure that in other words, make sure that your exit condition when your loop ends is chosen well, and make sure that the loop will hit it at some point. Like if you say, well, what you call, whoopsie daisy, do this loop while x equals 1, make sure that x gets redefined inside of the loop, because if it's not, it's always going to be 1. And your loop's always going to be going. All right, cool. Any questions? All right, yes.
When I printed the same while loop that you had earlier, mine printed 1, 2, 3, 4, and yours just printed 4.
Okay, I bet that I had a print statement somewhere.
It's because you have your print indented inside the while statement.
Okay.
Is that really
It's outside the while statement before.
Yeah, it's called anything that's indented is in the loop, and it's not indented is outside of the loop. I can take a look at it in a second if you want.
Okay.
But one note before everyone leaves, with your homework assignments, please make sure to submit all of your Python files. I want the actual files, meaning if I have a question with it, I want to be able to run it and see what's going on with your code. So the file that gets saved, submit it online. Yeah.
Well, if we already submitted our actual document,
Don't worry about it for this past week. Just do it in the future. Yeah.
So like, should we be able to like take code that we put into our document and copy paste it into?
You'd think that it's harder than you think.
Okay,
Yeah.
Because when I like transferred it into, I made sure that I could like copy
Oh,
and paste
okay.
it back and it didn't work.
Oh, nice. I've had a lot of I've had a lot of problems with it, especially with PDFs,
Okay.
and some people submit PDFs.